So question 7, again, building linear models from data. The following data represents the weight in grams of various candy bars and the corresponding number of calories. So if you're into this counting calories already, you may already be familiar with this. So the question is, does the weight of a candy bar affect how many calories would be in it? Well, to me, I would think so. I think it would be very close. I think as the weight increases, the calories would go up. So again, we have this data. Notice how the weight is X's and the calories is Y. So we can put this into the calculator using the stat button. So that's our first move, is to use the stat button. So I'm going to pause my video for a second and put this data into the calculator. You can do the same and come back and we'll see what we got. So now I have my data in my calculator. Again, what you can do, if you notice how if I move up here to L3, if I have some data below here, say 9 and 6, if I move up to L3 or any of these, L1, L2, whatever, if I move up and highlight this and hit clear, if I drop back down, it'll erase all the data that's in that list. So that's an easy way to clear your list as well. Also, if you go to stat, notice that number 4, if you hit number 4 there, hit enter. And then if you want to clear a certain list, so notice how you have L1, L2, L3, L4, L5, L6. If I want to clear L3, I could hit the second button and hit the 3. It'll say clear list L3, hit enter, and it'll clear list 3. Now, I didn't want to clear list 1 and 2 because I'm still using that data. So if I go back to edit again, you can see my data is still there. Now notice it was just all random. So I really couldn't see any patterns because the data was just all over the place. So what helps us organize it is do a scatter plot. So if I go to stat plot, notice that my plot is already on. If I hit enter, the type is already scatter plot. My X's are L1, my Y list is L2. That all looks good. So I'm ready to go ahead and graph. To graph, what we can do is hit the zoom button. And number 9, the zoom stat will create a scale for us without having to make our own. So to kind of run it out there for us. So that's what our data is kind of doing, is it's running around like that. To me, the best image of what I'm seeing is this one here kind of mirrors it pretty well. Now notice if I want to make it look more like theirs, I could change the windows. I could change the window. So they're saying like the X-min is 270. And they're saying the X-max is, I'm sorry, the X-min was 40. I apologize. Going the wrong way. So 40 and 70. It looks like the scale is going by maybe 5s, 45, 50, 55, 60. So it looks like the scales are going by 5s. The Y-min was the 270. The Y-max was 340. And that scale is also, looks like 280, 290, 300. Looks like that's going by 10s. So if I hit graph now, it probably looks more like what they have if I get my scales tighter. But again, if you don't want to get real precise, if you hit the zoom and number 9, it'll create a scale that will be good enough for us. So if you look at the window, notice that the X-min there is 44, while they're saying 40. The X-max is 65.8, and they're saying 70. So we're still the same similarity. Scale going by 5. Notice my Y-min here was 280, and they said 270. Y-max is 334, and they said 340. So notice again, the scales are not that far off. So that's why I kind of use that zoom stat to kind of get us in the ballpark. You can always tweak it from there if you need to. If you don't like this 44, you can round it to 40. 65.8, you can round it to 70. So you can clean these up as much as you want. So does the graph look linear? Notice how, again, it's not real linear, but it still looks somewhat linear because it still kind of runs in the same direction there. So I would say this is still kind of linear because it's kind of has a little bit of movement like a line. It's not all over the place. So if I want to find the equation of the line, they're suggesting to use the points 46, 292 and 64, 328. So I can use that information to find the equation of the line. So again, the slope is going to be the change in the y. So it's going to be 328, take away the 292, over the change in x's, which is the 64, take away the 46. So let me quit this. So again, quit is right above mode. Clear that off. So I have 328 subtract 292. And then on the bottom, I have 64 take away 46. Then if you highlight this 36 and hit enter, it'll copy it. And then if I want to divide by, highlight the 18, it'll copy it down. So 36 divided by 18, that will probably still just be 2. So our slope is going to be a 2. Now, to use the point slope formula, we have this y minus y1 equals this m times this x minus x1. Neither point looks all that great. I'm just going to use the smaller one. So y minus this 292 is going to equal then m is 2 times x minus x1 is this 46. So again, they want the equation in slope-intercept form. So I have to solve for y. So y minus this 292 is equal to this 2x, and 46 times 2 would be what, 92? 92, so 2x minus 92. Then if I add the 292 over to the other side, y equals 2x, and then we have this negative 92 plus 92. So negative 92, and I'm adding the 292 over to it. And that would be 200. That makes sense. So it'd be a positive 200. So that would be my line that I can use as a predictor. Y equals this 2x plus this 200. So if I want to graph that line, I can go y equals, and I can go 2x plus 200. And it should just go through the middle of the data. It looks like this is the best answer already, because I think that's the graph that we talked about. Southside is going through that data very similarly to this one. Got 3 points below, 3 points below. Yeah, that looks really good. Just don't have the exact same viewing window. So use the linear equation you found in part C to predict the number of calories in a candy bar that weighs 54.7 grams. So our function is going to be this y equals this 2x plus 200, I believe was the equation we had in part C. So remember, the x represents the weight of the candy bar and the y was the calories. So they gave us the weight that's going to go in for x. So y is going to equal then this 2 times 54.7 grams, and then I'll add another 200 grams to that. That's going to be a little bit over 300, isn't it? So I'll quit this and just let the calculator do this math for me. 2 times then 54.7, and then add the 200. And that gives me 309.4. So we do want the exact answer. Looks like they didn't ask about rounding. So 309.4 calories would be that. So if we look at the data, a 54 calorie candy bar up here, or 55 even, notice that is around the 300s. So that's the closest one. The 55.1 was 313. So that seems to be really close to what we were seeing. So if we want to interpret the slope, so remember the slope is this 54.7 over 1. So remember the y is the calories and the 1 is the weight in grams. So for every 1 gram, the weight's going to increase, the calories is going to increase by 54.7 calories. So if the candy has increased by 1 gram, that's where this 1's coming from, then the number of calories is going to increase by this 54.7 calories. So each gram is going to add an extra 54.7 calories of to that candy bar. So remember, a gram is like a weight of a paper clip. So if you ever see what a paper clip is, that's basically what a gram is, a decent sized paper clip. So that gives you an idea of what we're talking about. So if you've ever held a paper clip in your hand, that gives us an idea. So that concludes this question.